Logic gates are the building blocks of modern computers. Logic gates are tiny electronic circuits which perform very simple functions. By combining lots of gates we can create a processor which executes complex software. Early computers such as the BBC Micro in the 1980s contained thousands of gates. Today's computers contain millions or even billions of gates. Here is a simple electric circuit with a battery, a switch and a light bulb. For the bulb to light, electricity must be able to flow, and that requires a complete unbroken circuit. When the switch is in the off position, the switch contacts are open, so the circuit is broken. No electricity flows, so the bulb doesn't light. If we turn the switch on, the switch contacts close. This completes the circuit. Electricity can flow and the light goes on. Now let's look at a similar circuit, but this time with two switches, which we will call A and B. Both switches are currently off, so once again the circuit is broken and no current can flow. The light is off. Suppose we turn on switch A. The circuit is still broken because switch B is turned off, so the light stays off. Now let's turn off A and turn B on instead. This is a similar situation. The circuit is still broken and the light remains off. To turn the light on, of course, we need to turn on switches A and B at the same time. That way the circuit is complete and the bulb lights up. We can use a simple table to record whether the light will be on or off depending on the positions of switches A and B. This is called the truth table. In the table we will use the number 0 to indicate that the switch is off and the number 1 to indicate that the switch is on. For the light we will do the same. 0 indicates the light is off, 1 indicates the light is on. Now we can build up our table. We need to take account of every combination of switches A and B being either on or off. There are 4 possibilities. If both switches are off, that is A and B are both 0, then we know of course that the light will also be off, or 0. If switch A is on but switch B is off, the light is off. If switch B is on but switch A is off, the light is off. If both switches are on, the light is on. This is the completed truth table for the circuit. We call this an AND circuit because it requires both switch A and switch B to be on for the light to be on. An AND gate is a logic gate which is similar to our electric circuit, but instead of mechanical switches it uses tiny electronic switches called transistors. This is the symbol for an AND gate. It has 2 inputs, A and B, and 1 output. The inputs of the gate can take values 0 or 1. The truth table for this gate is exactly the same as before. If either input is 0, it is like one of the switches being turned off in our circuit. The output is 0. If both inputs are 1, it is like both switches being turned on in our circuit. The output is 1. That's all for AND gates. There are a few other basic gates you need to know about, and these will be covered in another video.